its radian, 4 pi over 3 minus pi. Okay, so this is pi thirds. Oh, sorry, 3 pi over 3. Okay. 4 pi minus 3 pi is pi, and then denominator should stay the same. So this is my reference angle. Reference angle is pi over 3. And that's from here to here is pi thirds. That's the measure. Okay. So why don't you try CYP 3A and 3B, and then once you're done, come check the answer. Okay, so your reference angle for the negative 200 degrees is 20 degrees, and your reference angle for 2 pi over 3 is pi thirds. Okay. If you got that right, you can move on to the next example. If not, here is your explanation. Okay. So negative 200 is here, okay? And then I changed it to find its coterminal angle positively, its positive coterminal angle, so I added 360, which is 160. Okay, and then so since this is in quadrant 2, that means it's 180 minus the angle. 180 minus 160 is 20 degrees. Okay. And then here, 2 pi over 3, just to graph it, I changed it into degrees, but if we're not graphing it, then that's fine. Okay, 2 pi over 3 is here. It's also in quadrant 2, so then it's pi, which is 180 degrees, right? Same thing. Pi minus 2 pi over 3, which is pi over 3. Okay, so then example 4, what it tells you, there's a chart here on things that are positive, when a function will be positive or negative, depending on sine, cosine, tangent, or its reciprocal. Okay. And then here is how it uses the following steps to find the value of the trigonometric function of any angle, right? The reason why is to know which one it's finding, right? So it's easier when you do sine, cosine, it'll find this angle. Okay. Okay. But an easy mnemonic device for us to remember is, in terms of sine, cosine, tangent, which trig function will be positive? Trig function will be positive. We think about it this way, that all students take calculus. Okay, obviously that's not true, right? Not all students take calculus, but that's just a little mnemonic device that we use to help us remember it. Okay. Trig functions, which one will be positive? Starting at quadrant 1 all the way to quadrant 4, all students take calculus. So this one tells us that all of the trig functions will be positive. This one tells us sine and its reciprocal cosecant will be positive. This one tells us that tangent will be positive as well as its reciprocal, right? And then this is for cosine and its reciprocal secant, right? So it's really based off of the original, but based off of that, then its reciprocal will be 2. Okay? So that's how we can remember that. Okay. So that chart on page 779, this is an easy way to remember it. Okay. On to example 4. Okay, so here it says find the exact value of each trigonometric function. Okay. So here it says use a reference angle to find a trigonometric function. You can, okay, I'll show you several ways to do it without using our calculator and just using our unit circle. Okay, so let's start with sine of 120. Okay. So 120 would be here. Right. Its reference angle, right? Reference angle, since it's in quadrant 2, would be 180 minus 120, which is 60. So then part of it is just telling us that sine 120 is the same as sine of 60. And then sine of 60 is square root of 3 over 2. Okay. Easy way to remember it is also if you have your unit circle, right? Sine is y. Sine of 120, y value of 120, square root of 3 over 2. So that's an easy way to write it. But the textbook just wanted you to practice using reference angle. But for a lot of these, I would just use my unit circle. So you have one. Okay. Okay, so using the next one for cotangent of 7 pi over 4. Okay. Where is 7 pi over 4? So this is it. 7 pi over 4 is here. This. Okay. So that means it'll be 2 pi minus 7 pi over 4. Right, since it's a quadrant 3, so reference angle would be 2 pi minus 7 pi over 4, right, which would be pi over 4. Okay, and then since the cotangent would be negative, right, this tells us that cotangent of 7 pi over 4 would be the negative, right? Cotangent is negative here because only these ones are positive. So this would be negative cotangent of pi over 4. Pi over 4 is square root of 2 over 2, so negative square root of 2 over 2. Or, yeah, there you go. Oh, sorry. So negative cotangent pi over 4. So that's y over x. So that's pi over 4. Sorry. That's y over x. So that's square root of 2 over 2 divided by the x, square root of 2 over 2. The book does not explain that at all. It just assumes that you're going to remember it or type it in the calculator. I have no idea which one. Okay, but then we're going to keep the first fraction, flip the second one, and then change the division to multiplication. Square root of 2, square root of 2 cancels. 2 cancels. This leaves us with negative 1. So cotangent pi over 4, negative 1. Or we could have also done it where we just did this divided by this. Okay. So why don't you try CYP 4A and 4B, and then once you're done, come check the answer. Okay, you should have gotten negative square root of 2 over 2 for 4A. You should have gotten negative square root of 3 over 3 for 4B. Okay, again, you shouldn't be using the calculator for this. You should just be using your unit circle. Okay. If you got that right, you can move on to the next example. If not, here is your explanation. Okay, so again, the book wants you to use the reference angle. If it didn't ask you to use that, you could just use the unit circle directly. Right. So like, if we didn't have to use our reference angle, cosine 135, here's 135, cosine is x, it's negative square root of 2 over 2. Okay. However, since it wants you to use the reference angle, that's fine. So reference angle, 135 is in quadrant 2, so that's why it's 180 minus the angle, which gives me 45. Okay. Cosine, however, in quadrant 2 is not positive, right? Only sine is. So that's why it's going to be the negative of cosine 45. And then cosine 45 is square root of 2 over 2, so that's why it'll be negative square root of 2 over 2. Okay. 4b, tangent 5 pi over 6. 5 pi over 6 is here, also in quadrant 2. So that's going to be pi minus 5 pi over 6. That gives you pi over 6. Okay. However, again, not positive for tangent. Right? It's only sine that's positive. So that means tangent 5 pi over 6 equals the negative of that reference angle, tangent of the reference angle, so negative tangent pi over 6. Okay, tangent is y over x, so if you look at pi over 6, y is 1/2, x is square root of 3 over 2. Okay? And it's divided by, right? Y over x, y divided by x, y divided by x. Okay, so how do we divide fractions? We keep the first one, flip the second one, and change that division to a multiplication. Then I can cross out the 2's here. This gives me negative 1 over square root of 3. Can't have a square root in the denominator, so I rationalize it by multiplying both top and bottom by radical 3, and it simplifies to this. Okay, next is example 5. Okay, so suppose theta is an angle in standard position. The terminal side is in quadrant 3. Okay, and secant theta is negative 4 over 3. We want to find the exact values of the remaining 5 trigonometric functions of theta. Okay, so let's draw this. So it's in quadrant 3. So several things that we want to probably talk about. Secant, right, is the opposite of sorry, not the opposite, the reciprocal of cosine, right? So cosine is x over r. So that means secant is r over x. Okay. That means r is 4, x is 3 here. Okay. And note that it's in quadrant 3. Okay. Radius can't be negative, so that means my x is negative, because it's here in quadrant 3, right? Which is x, y, here's my radius, right? X is going to be negative, y is also going to be negative. Okay, so that's something to keep in mind if it's in quadrant 3. Okay, so I have r, I have x. Okay, so then I'm going to put it into, we know that r equals the square root of x squared plus y squared. So r is 4, x, right here, one of them is negative, radius can't be negative, x is negative, which we know here. So that means x is negative 3, and plus y squared. Okay? So 4 equals negative 3 squared is 9. Okay? I'm going to get rid of the square by, I'm going to get rid of the square root by squaring. So that'll be 16 equals 9 plus y squared. Subtract 9 on both sides. That gives me 7 equals y squared. And then I'm going to square root both sides to get y by itself. It's plus or minus equals y. However, I know since it's in quadrant 3, y has to be negative. So that means y is negative square root of 7. Okay. Then, using that, I can now find my trigonometric functions. Okay. So now I know what x is, I know what y is, I know what r is. So in case that's unclear from here, I know that r equals 4, x is negative 3. Okay, so let's find the other 5. So sine theta is y over r. So y is negative square root of 7, and then r is 4. Okay. Cosine is going to be the opposite of this, so then I already know it's negative 3/4. Sorry, not opposite, reciprocal. Okay. Tangent is y over x, so that means it's going to be negative square root of 7 over negative 4, which simplifies to square root of 7 over 4, right? That's why it's tangent is the one that's positive, right? All students take calculus, take tangent. It's positive there. Okay, then let's do the reciprocals. So cosecant theta then would be the flip of this. This would be 4 over negative square root of 7. Can't have radical in the denominator, so I'm going to rationalize it by multiplying both top and bottom by that radical. Okay, it simplifies to this. Okay. Secant, that was what we were given, so the next is cotangent. Okay. Reciprocal, so that means 4 over square root of 7. Okay, again, can't have square root in the denominator, so rationalize both sides. Well, it's 4 square root of 7. 7. And there you go. Oh, sorry, my bad. I put in the wrong x here. X is 3. So there should be negative 3. 3. It should be 3. It should be 3. Just go to 7. Okay. So why don't you try CYP5, and then once you're done, come check your answer. Okay, you should have gotten sine theta is negative 2 square root of 13 over 13. Cosine theta is 3 square root of 13 over 13. We already have tangent. Cosecant theta is square root of 13 over negative 2. Secant theta is square root of 13 over 3. And cotangent theta is negative 3/2. If you got that right, you can move on to our last example. If not, here is your explanation. Okay, so tangent is y over x. Okay, tells me that this is in quadrant 4. Okay, so in quadrant 4, x is positive, y is negative. So here, if it's negative 2/3, the negative is going to go with the y, okay, which is why here I wrote y is negative 2, x is positive 3. Okay. Then finding the radius. Radius is x square root of x squared plus y squared, so square root of 3 squared plus negative 2 squared. 3 squared is 9, negative 2 squared is 4. 9 plus 4 is 13, so radius is square root of 13. Okay. Sine is y over r, so y is negative 2, radius is square root of 13. Rationalize the denominator, this is what you get. Okay. Cosine is x over r, so x is 3, r is square root of 13. Rationalize the denominator, this is what you get. Okay. Cosecant is the reciprocal of sine, so then I just flip these two, so now it's square root of 13 over negative 2. Secant is the reciprocal of cosine, so flip these two, so then it's square root of 13 over 3. Okay? And then cotangent is the reciprocal for tangent, so then flip these two, so that's why it's negative 3 over 2. And there you go. Okay, so moving on to example 6 here. In a robotics competition, right, a robotic arm 4 meters long, so here you can see this robotic arm is 4 meters long, right, is to pick up an object at point A and release it into a container at point B. Right, so here it is, and then I'll take it and move it here. Okay? The robot's arm is programmed to rotate through an angle of precisely 135 degrees to accomplish this task. What is the new position of the object relative to the pivot point? Okay? You want to know what this point is. So here, since this is our circle, r is going to equal 4. Okay. And then, so we need to find x and y. Okay. Okay. So then here, we're going to find cosine 135 and sine of 135. Okay. So cosine of 135, is going to be x over r. Okay. And then here, because technically I guess the book doesn't have this learn the unit circle yet, we could technically just put in this here. Okay. But because it doesn't have us learn it yet, it wants us to use reference angle. Okay, so I'm going to use reference angle here. Reference angle. Since it's in quadrant 2, 180 minus 135 equals 65. Sorry, 55. No, sorry, 45. Why can't I do that? 45, right? Okay. And then if you remember the whole all students take calculus, if it's here, cosine is negative. So what that means is this is the same as negative cosine of 45. And I can fill r with 4. All right, radius is 4. Okay. Negative cosine of 45 is negative square root of 2 over 2. I'm going to multiply by 4 on both sides here. Okay. The reason why I put the parentheses is because this negative is not a minus. I don't want to do 4 minus this. I want to do 4 times this. Okay. And this will give me x. 4 to 2, this is negative 2 square root of 2 is my x. Okay. I'm going to do the same thing for sine. So sine 135 equals y over r. Okay. Here, again, reference angle. Sine is positive, so I can just take my sine 45 as is. Okay. Y over radius is 4. So sine 45 I know is square root of 2 over 2. I get rid of the divide by 4 by multiplying by 4. And this gives me 2 square root of 2 equals y. Okay. So my point is at negative 2 square root of 2 for the x and 2 square root of 2 for the y. Okay. So you don't have to go through this step and this step if you know the unit circle. Okay. So with the unit circle, I could just go directly cosine 135, look at my unit circle, that's negative square root of 2 over 2. Sine 135, look at my unit circle, that's square root of 2 over 2. You can eliminate this middle step if you know your unit circle. Okay. Okay. So why don't you try CYP 6, and then once you're done, come check your answer. Okay, so something I missed from before, since it wants a position, it's not just a point because it's not on an ordered plane. Okay, so 2.2 is about, 2 square root of 2, and since this is x, this is left, this is positive, so this is up, so it's actually left about 2.83, and about upwards 2.83 from the pivot point. Okay. So then, for CYP6, this is the point you should have gotten, okay, which means that it's left 3.5 meters down 2 meters. I just don't know why, if you're going to use a calculator, why you need all of this stuff and why you would do it that way. Like if you're going to do it with a calculator, just type it in. So it's weird how the book kind of combines it. I think it just wants you to practice some of your unit circle stuff and things like that. But ideally, if you're going to eventually use a calculator, why not just use that? But, yeah, so your new position would be it's left 3.5 meters from the pivot point and it's down 2 meters from the pivot point. Okay. If you got that right, you can get started on your homework. If not, here is your explanation. Okay. So if it's going to move another 75 degrees more, so originally it was already 135, plus 75 is 210 degrees, right? And then technically, if we're going to use our unit circle, and if we already have that, we could take out this whole middle step here. Right? If we had our unit circle, we don't have to do any of this here. Okay. But it hasn't expected you to know your unit circle yet, although all of a sudden later on in the lesson it just automatically assumes that you do know it. So we're just going to use the unit circle. Okay, so sorry. So reference angle then, assuming we don't know all of the unit circle and just part of it, the reference angle would be 30. Okay. And since 210 is in quadrant 3 now, only tangent is positive, which is why here you see it as negative cosine 30 and negative sine 30. Okay. So replacing cosine 210 with this, replacing sine 210 with this. Okay. Then replacing cosine 30 with this, replacing sine 30 with this. Although, obviously, if you knew cosine 210, you could just automatically get this whole thing. You knew sine 210 from your unit circle, you can automatically get this. Multiply by 4 and simplify. So x and y. And since this is negative for x, that's left. Since this is negative for y, that's down. So that's why it converts into left 2 square root of 3, down 2. Or more, technically this is the exact answer. But giving it in more layman's terms, left 3.5 meters. This is about 3.5. Down 2 meters. There you go. So that's it for today. Have a great rest of the day. Bye, guys.